Hello again, my name is Marcelo, and today I'm going to be doing Project Euler problem number 9. This one is about Pythagorean triplets. So if you don't know what a Pythagorean triplet is a set of three natural numbers a, b, and c in a sequence, which the biggest one square equals the sum of the square of the two smallest ones. So a square plus b square equals c square. As an example, we have that 3 square plus 4 square equals 5 square. And then it claims that there exists only one Pythagorean triplet for which a plus b plus c equals 1000, and then you have to find the product of these three numbers. There are many ways to do this. If you read up on trigonometry and theory, you can find ways to do it with Euclid's formula, but since it doesn't really offer any uh, performance gains here or any complexity order gains, we are actually just gonna do with the kind of brute force approach, which is we loop through possibilities for two of these values and then guess the third value from this formula, and then from there we'd have an answer if it satisfies this equation. And then from there we can get a little bit smarter and just think about how to do this. So I'm going to be starting here. I'm using Python. You can use whatever programming language you want. The idea here is again that a plus b plus c equals 1000, and then you know that by the Pythagorean triplet that a square plus b square equals c square. And to not be dealing with an absolute number, let's call here n equals 1000. And the idea is that if we just go through for in a range, a in a range and then b in another range, we can get c from the complement of a and b. And then if we check that formula, that c square equals a square plus b square. And if this is true, then let's start with a small variable that starts as no or none here, and just make it equal to the product and break out of the loop, and then we can break out of this loop as well if that variable has been fulfilled. And at the end, to finish things, we can just print that number. But we can go a little bit smarter here. So instead of doing, I know that variable names don't matter that much, but instead of doing a and b, the smaller ones, let's start with the biggest one. So this way you can kind of reduce the number of iterations we do. So we know that C is the biggest one of the three since it's in a sequence. And this means that C is bigger than A and C is bigger than B. But you know, by trigonometry theory, that C cannot be bigger than A plus B. So these two numbers have to be bigger than C to form a triangle, which means that C is less than half of this number n. So if we were to change here, we know that C is at most half of n. And for as little as it is, so we know that it has to be bigger than a and b, so it has to be at least 1/3 of this value, because otherwise either a or b would be bigger. Let's delete this now for now. So we can replace this with n divided by 3. And now, instead of getting C here, we just get A instead and replace it with C. And for B, we know that B is not bigger than C, so it's the upper limit of our range. And we can consider that it's bigger than A and smaller than C. So since it's bigger than A, the rest of the value here of 1000 that it complements and minus C, it should be somewhere around that area between n minus C and C, but we have to leave some room for A as well, so it's this divided by 2. So because it's bigger than A, it's bigger than the half of the complement, and then it's not bigger than C. I know this might sound a little bit confusing, but if you review the math, it kind of checks out. So I think this is enough. So if you were just to run this right here, we get the right response. So again, very simple, but simply by using these calculations here and inferring the values of C and B, we can kind of cut the number of iterations by at least 1/6. It maintains the same complexity order, which is n2. So the bigger n grows, the more this will grow by the quadratic complexity. But we'd make less comparisons by just reducing the range here. And yeah, it's a little bit of parameter optimization, but it works well enough. Again, this was pretty simple, but I hope you liked it. If you like it, please like the video, comment, and subscribe. I would love to get any suggestions on what to work on next. But for now, thanks for watching, and I'll see you in the next one.